G'day guys, we've got an applications of differentiation question for you today, specifically a chain rule question. Now we've got the rotating light of a lighthouse rotates at 5 revolutions per minute. The lighthouse is located 3 kilometers from a straight coastline. Okay, so I've drawn a little picture for us today and we've got this 3 kilometers right here. So the question is, how fast does a beam of light move along the coastline at the instant it passes a point on the coast that is 4 kilometers from the lighthouse? Okay, so we're also given this one here. Great. So let's just weigh up what we need to find out. How fast does a beam of light move along the coastline at the instant it passes a point on the coast that is 4 kilometers from the lighthouse? Okay, so here's a little point that we have to work out, and we're looking at the velocity that the point of light is moving in this direction if we assume that the lighthouse is rotating in that way. So this is going to be a velocity, or I'm going to call this dx dt. Okay, so we are looking for this dx dt. Now what else have they given us? We're also given the fact that the lighthouse rotates at 5 revolutions per minute. Okay, so if a full revolution is 2 pi radians, so this is going to be 10 pi radians. So we can actually write that one down. Our change in angle with respect to the change in time is equal to 10 pi per minute. Great. Okay, so let's go on. What else do we need? We've got this. We've got this. Now we're going to use the chain rule from here to work out what else we need to find. Okay, so if we've got dx dt and we have d theta dt, we need to figure out what dx d theta is. And the reason I know that is because I'm going to use this chain rule relation. Dx dt is equal to, we've got this one, d theta dt multiplied by, now I need to cancel out my theta, so my denominator is going to be d theta, and my numerator is going to have to be dx, because that's what I need. So I'm going to have to work out what x is, in this case that side of the triangle is, with respect to theta. Okay, let's do that. So I know that I have a 3 kilometer side here that's fixed, and I'm looking for this x here, so I can say that the tan of my angle is equal to x on 3, or if I want x in terms of theta, let's put a little comma, x is going to equal 3 tan theta. Great. So we need, for the chain rule, we need dx d theta. So I need to differentiate x with respect to theta. So hopefully you guys are aware of how differentiation, specifically trigonometric differentiation, works. So I'm going to write dx d theta, and it's not a very complicated one. The derivative of tan is 1 on cos squared. So I'm just going to say this is equal to 3 on cos squared theta. And now we have all of the information that we need to compute the solution to this problem. Okay, so I'm going to change color, make it easier to understand. What have we got? Let's just go straight back to blue. So I'm going to say that dx dt is equal to d theta dt, which is 10 pi, multiplied by dx d theta, which is 3, divided by cos squared theta. Now let's simplify that for our, to make it easier for ourselves. This is going to be equal to 30 pi over cos squared theta. Okay, well that still hasn't given me a velocity yet, so what else do we need to figure out? Well, if we have a look, we've got a distance that it is from the lighthouse, so we actually have this hypotenuse. So what we can do is we can use this hypotenuse and this adjacent side to calculate what the theta is at this moment. So what we're going to do is I'm going to, where am I going to put it? Oh, I'll put it up here. Theta is going to be equal to, at this point, the arc cos, or cos to the -1, of adjacent over hypotenuse, which is equal to 0.723 radians. Okay, so what I can do now, finally, I can evaluate, so I can go dx dt evaluated when theta equals 0.723 is equal to, now just put that in here, 0.723, and I get 168 kilometers per minute. Now it's always important to leave the solution in the units that we were given in the question. So distance, we were given kilometers, and time, we were given minutes. So it's important that we leave our solution in kilometers per minute rather than meters per second or kilometers per hour, like things that we'd be used to seeing. So let me just fix this up for you guys to make it easy to see. 168 kilometers per minute. Okay, so let's actually go back through and figure out, a good sort of black box method that you can use to solve a question like this in an exam situation. So first of all, like any maths question, define what you're given. Figure out all the different bits and bobs that you're given in the question. In a question like this, obviously draw a picture. It's important that if they haven't given you a picture, you draw one to make sure that you understand what the hell's going on and how all the relations work. I couldn't solve this question without a picture. Even though I've done it a million times, I still need to put my picture down to ensure that I'm getting all of my data in the correct places. Once you've done that, identify the fact that you've got variables in terms of other variables. So this for me is a red flag that it's going to have to be a chain rule sort of situation. We have the chain rule happening here. Okay. Once we've got our chain rule, once we've sort of understood, or you've taken the plunge with the chain rule with the question, write down the what you're looking for and what you have in terms of the relations, and then you can sort of work out what you need. That's what we did here. We knew that we needed dx dt. We know that we had d theta dt, so we could just figure out what we needed to figure out to cancel out the thetas and be left with dx dt. So once we got this relation, we were then able to figure out what it was. We can go searching for it, so to speak. Once we've done that, we just enter in all of our relations, simplify it down, substitute in our values that we need, and we come out with a solution. So, I usually say this is not that a hard question, but, it is a bit tricky if you're starting for the first time. I would recommend going through a couple of these changing angle sort of situation problems with relation to the chain rule, because, if you're doing any kind of calculus, final year high school course, these will come up. It's almost a guarantee. So I hope this video helped, guys. If it did, give it a thumbs up, subscribe to my channel. I put out new videos as often as I possibly can. But until next time, guys, enjoy your maths.